Our topic for today is a tangent and normal line. Tangent is line that touches the curve at a point and doesn't cross it, whereas normal is perpendicular to that tangent. If we look at the figure, we see that there's a straight line and a curve touches at a certain point P, x sub 1 and y sub 1. Also, the line crosses is a normal line at the same point P, x sub 1 and y sub 1. Let the tangent meet the curve at P, x sub 1 and y sub 1. Now the straight line equation which passes through a point having slope m could be written as y minus y1 equals to m times x minus x sub 1. This m is sometimes called the gradient, and this is the slope. We can see from the above equation the slope of the tangent to the curve y equals a function of x and at the point. The point x sub 1 and y sub 1 is given as dy dx at p. Point x sub 1, y sub 1 equals to first derivative of function of x equals to y prime, or simply as m. Therefore, equation of the tangent to the curve at P can be written as y minus y1 equals to m times x minus x sub 1. That is for the equation of the tangent. And also, the equation of the normal to the curve is given by y minus y1 equals to negative reciprocal of the slope, or the first derivative, times x minus x sub 1. If we notice that the difference of this slope for the tangent, the first derivative is for the tangent, and the reciprocal of that slope is for the normal line. Example, find the equation of the tangent and normal lines to the curve y equals to 3x squared plus 2x plus 3 at the points 0 and 3. The 0 indicates the x value and the 3 indicates the y value. We have the solution. This is the equation of the curve. Now we first get the first derivative. In power formula, 3 times 2, x plus 2, is give us 6x plus 2. At 0, 3, that is a point where the tangent and normal line occurs. We plug in the value of x, 0, at the first derivative, y prime equals to 6 times 0 plus 2, which give us 2. This is the y prime equals to m, or the value of 2. For the equation of the tangent line, we use the first derivative, the value of m. In the general form of the line, we plug in the value of y1, x1, and the slope. We indicate t for the tangent line. Y minus y1 equals to m of t, x minus y sub 1. Y minus 3 equals to 2 times x minus 0, which give us y equals to 2x plus t. This is the equation of the line in the form of y equals to mx plus b, which b is the constant and the m is the slope and the variable of x and the y. For the equation of the normal line, we first get the slope of the normal is equals to negative reciprocal of the slope of the tangent, which the first derivative equals to negative 1 half. So thus we have y minus 3 equals to negative 1 half times x minus 0, which gives us y equals to negative x over 2 plus 3. We notice that we have imaginary one here. So we have the slope negative 1 half. So we have the form y equals to mx plus b. So the m here for the normal is negative 1 half. That is the equation of the tangent and normal line for this example. Another example, find the equation of the tangent and normal lines, the curve x squared plus 3xy plus y squared minus equals 3 at a point 1 and 1. We notice that this curve or the equation, we use the implicit form of derivative because we have a mix of x and y into the equation. So we have the solution x squared plus 3xy plus y squared equals to 3. By getting the first derivative by power formula and the product rule, 2x plus 3, we isolate the constant from two variable because this is the combination of 3x and y. Supposed to be we have three combinations, but in the long run of the solution, one of the three combination eliminated because we have the derivative of the constant is 0 and multiplied to other variable makes 0. So we have two combinations only. To simplify, we first isolate the 3, then we have the product rule to x and y. So simply x, then derivative of y is the y prime. Every time we get the derivative of y, we put a y prime. Plus y, and the derivative of x is 1, plus the derivative of x squared is 2y and y prime equals 0. The derivative is 0. And distribute the 3 to the two terms of the equation 2x plus 3xy prime plus 3y plus 2y y prime plus 0. Then we separate and isolate all the variables and term that has a y prime, and to other side is the 2x plus 3y, and we isolate the y prime that give us 2x plus 3y over negative 3x plus 2y. We have two variables in that slope. So we use the 2 points, which is x1 and y1, to get the value of the slope. So we have y prime equals to 2 times 1 plus 3 times 1 and negative 3 times 1 plus 2 and 1. We have 5 over 5 equals to negative 1. This is the slope of the tangent. The first, the slope that we get is the slope for the tangent line. So for the equation of the tangent line, we shall use the general form of the line, that is y minus y1 equals to m sub t x minus x sub 1. So we plug in the value of y sub 1 and x sub 1, also the slope for the tangent. So we get y equals to negative x plus 2. Also for the equation of the normal line, for the equation, we have first to get the slope of the normal, which is negative reciprocal of the first derivative of function or the y prime or the slope of the tangent equals to negative 1 over negative 1. So we make a positive. Thus we have y minus 1 equals to 1 and y equals to x plus 0. So we have y equals to x. So that's the two equation. We have the equation of the tangent line, and for the normal, y equals to x. Also, for example, another example, find the equation of the tangent and normal lines in the curve y equals to x cubed minus x for 6x squared plus x plus 3 with a slope of 1. So this give an example. We don't have a 2 points for x sub 1 and y sub 1. The only given is the equation of the curve and the slope. So we have the solution. First thing to do is to find the first derivative. Y prime is 3x squared minus 12x plus 1. Since the slope for y prime is 1, we use that in this first derivative. We plug in, and 1 equals to 3x squared minus 12x plus 1. We get 3x squared minus 12x equals to 0. Now we simplify this to find the value of x. So we have two value of x. One is the x equals to 0, x equals to 4. So we have two value of x. In this case, we also find values for y. When x equals to 0, y equals to, we plug in the value of x to the original equation, which is here, the original equation, 0 raised to 3 minus x times 0 raised to 2 plus 0 plus 3. So we get the value of y is 3. When x equals to 4, we plug in the value of x also to the original equation, the curve, y equals to 4 raised to 3 minus 6 times 4 raised to 2 plus 4 plus 3. We have negative 25. So we have two values of x and two values of y. So we expect that we have two equation for tangent line and two equation for normal line. At the point 0 and 3, which is x equals to 0 and y equals to 3, For the equation of the tangent line, we have y minus y sub 1 equals to m t x minus x sub 1. We plug in the value y minus 3 equals to 1 times x minus 0. So we have the equation of the line is y equals to x plus 3. That is the equation of the line. For the equation of the normal line, at that point, first we get the slope of the normal. So we have negative reciprocal of m sub t equals to negative 1 over 1. We have negative 1. Then we plug in, thus we have y minus 3 equals to negative 1 times x minus 0, which is value of x is 0. We have the equation of the normal line. So we have equation for the tangent and normal line at point 0 and 3. Another normal and tangent line at 4 and negative 25. For the equation of the tangent line, same procedure. We have y plus 25 because we have negative 25 and negative y minus y1, and this is negative, so that makes it positive here, equals to 1 times x minus 4. So we have equation of the tangent line. For equation of the normal line, for the point 4 and negative 25, we have y plus 25 equals to negative 1 times x minus 4. So we have y equals to negative x minus 21. So there's a two equation of the tangent lines and two equations for normal line because we have two value of x and two values of y. So I hope that you have learned this topic. Thank you very much.